Hello, Prep 2. Here's the geometry part, and I'll start by Unit 4. It's talking about medians and the isosceles triangle. The medians here in the triangle, any triangle you have, 3 medians. Any triangle has 3 medians. And the medians of triangle, the 3 medians of the triangle are concurrent. The 3 medians are concurrent. If you have the median from A to D, the meaning of median that the line segment drawn from the vertex to the opposite base. The 3 medians drawn from the 3 vertices must intersect at one point, and this point M called the point of concurrence. Means the point M divides each median in 2 ratios. You can have the ratio from the base or the ratio from the vertex. The ratio from the base means from this side it will be 1 to 2 from the base, 1 to 2 from the base, or from the vertex it will be 2 to 1 from the vertex. Here AM is the part which is from the vertex, it will be 2 to 1. Also you can have the ratio in the median itself, and I'll talk it later. Number 1, from the base. Here if you have the base BC and the median AD. In this median, MD here is the part coming at the base, and AM is the part drawn from the vertex. The ratio will be 1 to 2, and it differs whatever the number you have or the length of the median you can have. Also 2 to 1 from the vertex, and comes in complete and choose questions, so you must know it. It's 2 to 1 from the vertex. About the ratio with the median itself. If the median here AD means all of it will be 3. 2 plus 1 is 3. Means when I talk about the ratio from the AM part or the part from the base to all of the median, means it's 2 from the vertex to all the median AD, means 2 to 3. AM to AD will be 2 to 3. Another part which is MD, it's at the base. From the base here it's 1. All the time it's fixed ratio, here is 2 and here is 1. The fixed ratio or the fixed number in the base is 1, but all the median is 3. AD is 3. Then you can have the ratio between DM, I say that's 1. And instead of saying 1 to 2, you can say it's half AM. Half AM means it's 1 and AM is 2. But AM is double DM. Double means 2 over 1, or you can say it's 2 only, 2 from DM length. The DM part, or the MD, here it's in the base, and he need to compare it with all the median. So in the base it's 1, and I need to compare it with AD, which is 3. The median is 3. Also AM from the vertex it's 2, but it's 2 comparing with the AD, all the AD is the median, it will be 3. So it's 2 over 3, 2/3 of the median AD. You can have also medians in the right-angled triangle, but in the right-angled triangle you have a hypotenuse, and the hypotenuse, if you remember, it's the only side which comes opposite to the right angle. All the time in the right-angled triangle, 2 parts will be half of the length of the hypotenuse. One of them is the median drawn from the vertex of the right angle. It will be half the hypotenuse. Also the side opposite to the 30 degree in the right-angled triangle. And the 30 degree here can be drawn, it's 90 degree for the right angle. The 30 degree means it's 30-60 triangle. If you here have 30 and here 60, it will be 30-60 triangle. And I'll give you example about it later. Exercise 1 is talking about the medians and the relation between them. If you have 2 medians or more, and you need to calculate the perimeter of the small triangle here. The givens in this triangle ABC are that AF and C are two medians in triangle ABC, and both of them intersect in one point, which is concurrence point. It's called M. The length of AC, this side, is 12 centimeter. It's given that this part is 12 centimeter. And it's given that AM, 8 centimeter, but it's not written. Just this part is 8, from A to M only. CD means all that median is 9 centimeter. All of that, it's 9 centimeter. Means here it's given all the median, but here AM, it's just the part from the vertex. He needs to calculate the perimeter of the colored triangle here, MFD. First of all, if you don't have given they are medians, you have to prove that they are medians. And the proof that they are medians is that you have midpoint and it comes from the vertex, so it's median. But he gives you that AF, CD are two medians in triangle ABC, and they are intersect in one point M. It's the concurrence point. All of that are enough to prove the relation or the ratio between MF and the AM or any other two parts. Let's start by any side of the three sides of the perimeter or of the triangle MFD. You need to calculate MD and MF, DF also. Here I'll start by MF. Here, from the concurrent point to the point at the base. It's given that AF, the median, the part AM is 8 centimeter. Then you can say that if this part is AM, then MF is half AM, means MF equal half 8 centimeter, which is 4 centimeter. This part will be 4. By calculation, this one, it will be 4. And then also the CD is given. It's a median, and the length of all of this median is 9 centimeter. I can get the length of MD. MD comes at the base or the vertex. Yes, it's at the base, like you said. MD at the base will be 1 over 3, not over 2, because you have here, it's all the median is 9. Then it's 1 over 3 of all the median, which is CD. Then 1 over 3 multiply by 9 centimeter give you 3 centimeter, and it's the length of this part 3 centimeter. The remaining part is DF, and it's not a median here, it's just a line segment connecting between two midpoints in this side. If you have two midpoints here and a line connecting between them, opposite to it, a line which is AC is 12 centimeter, then DF will be half AC. If DF half AC, then it's 6 centimeter. Now you have the three sides of the triangle. One of them 3, 4, and 6. If you add them together, you get the perimeter of the triangle, because the perimeter of any polygon equals the sum of all side lengths. Then the perimeter is 13 centimeter. That example about the medians. Another example number 2, is talking about the right-angled triangle. In the right-angled triangle, here you have, this is given 30 degree, and D is midpoint of AC. If you have the three givens here, and he asks about A, B, D, he needs to prove that it's equilateral triangle. Means he needs to prove that AD equal DB equal BA. If all of the three sides are equal, it's called equilateral triangle. Since measure of angle B equal 90 degree, and D midpoint of AC, you can get two things. If this one is right angle, the line drawn from this vertex BD to the other opposite side, which is hypotenuse, then BD will be half the hypotenuse, means half AC. BD half AC. And that's the conclusion number 1 that you get. Another thing, AD, since that D is a midpoint, AD also will be half all of AC. If AD half AC, also we say that BD half AC. If you get that AB half AC again, it's meaning you get what you want. AB equal half AC, because measure of angle C equal 30 degree. If measure of angle C see 30 degree in the right angled triangle, we said that the opposite side to this angle will be half the hypotenuse, which is AC. From 1, 2, and 3, we get that BD equal AD equal AB, because all of them are halves of AC. Then this triangle ABD is equilateral triangle. All of that part is talking about lesson 1 and 2, which is median. The other part, lesson 3, talking about the isosceles triangle and their corollaries, also the equilateral triangle and the properties of equilateral triangle, all of them included. The isosceles triangle here, if you have ABC is isosceles triangle and the two legs of it is AC and AB, because AC equal AB, then these two sides are equal in length, and the triangle with two equal legs called the isosceles triangle. BC here is a base. If you have the base angles of the isosceles triangle are congruent here, you get that the two legs are equal, and also the theorem said if the two here sides equal in length, then the two base angles will be equal, means the opposite angles, B and C, are congruent. The base angles are congruent. The two sides opposite to these angles are congruent also. Then the relation here between the side and the base angles are the same. What about AD? AD here we can call it in the corollaries 3 names. The 3 names, one of them can be median, as I said in the first lesson, that AD is a median. When AD is a median, it will bisect the vertex and it will be perpendicular to the base. Bisect the vertex and perpendicular to the base. We can call also AD another name, which is the bisector of the vertex. It's already bisecting the vertex, means this part equal this part. If it's bisecting the vertex, it will bisect the base and also be perpendicular on it. Bisector of the vertex, bisect the base, and perpendicular to it. Means the 3 elements here you can have in the isosceles triangle using the median will be the same. And also we can call this line axis of symmetry. AD can be axis of symmetry, but you can have 2 conditions. The 2 conditions are that AD perpendicular on BC. Also you can have that AB equal AC, means it must be an isosceles triangle to have 1 axis of symmetry. And for your information, you have to remember that the isosceles triangle has 1 axis of symmetry. Remember that. I need you to remember also another point, that it's called that any point on axis of symmetry of a line segment is at equal distance from its terminals or from its end points. What the meaning of that? The meaning of that, if you have in this shape, AB is a line segment and the line L is a line which is perpendicular to it, or we can say that the line L is the axis of symmetry of this line segment. This axis of symmetry, L, perpendicular to the line segment and divides it into 2 equal parts. This part, BC, equal this part, AC. If the line L perpendicular and coming at the midpoints of this line, we can call it axis of symmetry. Then this axis of symmetry having a property which saying that the line segment is at equal distance from its end points. Equal distance means any point you have on the line segment, I said on the line segment, means point E or point F, both of them are on the line which is called axis of symmetry, having an equal distance from here, from E to B, equal from E to A, and the point B, the point A, called end points. Here also from C to B, from C to A, equal distance. From F to A, from F to B, also equal distance. Listen here, you have E EA, the end point here. EB, the end point here. CA, CB, all of them ends with the two letters A and B, which is the 2 points of the line segments. Then, if I say it, since E and C and F lies on the line or on the axis of the line segment AB, means all of them are equal, and it comes in complete and choose question, and it's a very important part. I need to remember that the equilateral triangle here has 3 equal sides. Remember, the equilateral triangle with the 3 equal sides, 3 equal or congruent angles, and all of them equal 60 degree. 180 divided by 3 will be 60 degree. And the number of axes of symmetry, because they are all equal in length, it will be 3 axes of symmetry. That about equilateral triangle. Also remember that the measure of exterior angle of the equilateral triangle will be 180 degree, because the interior is 60. If the interior is 60, then the exterior will be 120, because they are supplementary to each other and comes on one line and supplementary. Example number 1 on the isosceles and the equilateral. Here you have triangle called XYZ. It's equilateral triangle, and he didn't make dashes here, so pay attention. You have to read the givens very well. XYZ is an equilateral, and in the other triangle ZYL, you have that LY equal LZ also given. The measure of angle YLZ equal 80 degree. Required to find using proof that measure of angle XZL. He needs to find the measure of this shaded part. Only this part, not all of the angle Z. Means you can have all the angle Z and subtract this part from it. If you know the measure of angle Z, and if you know the measure of angle LZY here, you can know the measure of this part. Let's talk about the big triangle, which is XYZ. It's equilateral, right? Since XYZ is an equilateral, then all the 3 measures of this triangle equal 60 degree. Measure of angle X equal measure of angle XYZ equal measure of angle XZY. All of them is 60 degree. In the other triangle inside, triangle YLZ, you have only one angle given, which is 80. But if you have one angle and the 2 equal sides in it, means it's isosceles triangle. The isosceles triangle can give you that the 2 base angles are equal in measure. Means the measure of angle LZY equal measure of angle LYZ. LZY equal LYZ. And both of them will be 180 minus 80, which is the vertex angle, dividing by 2, because they are 2 equal or 2 congruent angles. Both of them will be 50 degree. At the beginning, we find that the measure of angle XYZ equals 60 degree, and XZY also is 60 degree. XZY is 60 degree. He asked about XZL, means we need XZY, which is 60 degree, and the other part is 50 degree. If we subtract 60 from 50, we will find that the measure of angle XZL from 1 with 2, that 60 minus 50 will be 10 degree. Means the small part here will be 10 degree. That's about exercise number 1. Exercise number 2. You have 2 triangles, and one of them he gives you that ABC is an equilateral triangle, but he mentioned also that AB equal AC equal CD and also equal DC. CB and DC, excuse me. The point D belong to BC. The point D belong to BC. Pay attention, he needs to prove that BA perpendicular on AD. BA perpendicular on AD. If he needs to prove that 2 sides perpendicular to each other, means he needs to prove that the point here of the repeated side, the repeated point here, A, means he needs to prove that measure of angle A is 90 degrees. If you proved that measure of angle A is 90 degrees, I need you to prove that. How to prove that measure of angle A is 90 degrees? First of all, talk about triangle ABC and then decide to move to another triangle. Triangle ABC is an equilateral. All the three sides are equal, means all the three angles will be equal in measure, which is 60 degrees. Then you get a part from measure of angle A, which is 60. If you know the part here, you will know that it's 90 degrees. How to know the other part? You can use the other triangle, which is ACD. Do you know any angle of triangle ACD? We didn't know the measure of any angle in the givens, but he can give you that this one is 60 and you can calculate then this angle is supplementary to it and you will find it's 180 minus 160, it will give you 120 because this angle called exterior angle, or as I said before, any exterior angle of equilateral triangle equal 120, then you can say this one is 120 because it's exterior without steps. Then also you can have the measure of angle CDA and CAD. Do you notice that here DC and AC are equal in length? When the two sides here are equal, the two base angles will be equal also. This two angles, this angle and this angle will be equal in measure. If the two sides AC equal DC, then measure of angle A, including this and this, 60, and the other part, you can find it. I said that CAD equal 180 minus 120 divided by 2 to give you the two angles here. Both of them are 30 degrees because 180 minus 120 is 60 and you divide the 60 by 2 to get both of them are 30 degrees. If the two of them are 30 degrees, then from 1 and 2, number 1 is 60, number 2 is 30 degrees, then 60 plus 30 give you the measure of angle A. Measure of angle A including BAC and CAD added together give you 90 degrees. If you get the measure is 90, then BA perpendicular on AD. Exercise number 3, triangle XYZ, given that XY equal XZ means it's isosceles triangle. The measure of angle MLZ in the small triangle MLZ is 55. Measure of angle X is 70 degrees. What he need to prove that measure of that the length ML equal the length MZ in the small triangle ML, he need to prove that it's equal MZ. If he asks to prove that two sides are equal in length, you need to prove that the two opposite angles are equal in measures. ML opposite to it, measure of angle Z. And ZM opposite to it, the angle which is given here, 55. If you find that this angle is 55 or it's equal to this one, your proof is done. First of all, the triangle XYZ have more givens, which is that XY equal XZ means isosceles triangle. If this is isosceles triangle and this side equal this side, means that the two base angles Z and Y equal in measure. Then measure of angle Z and angle Y equal 180 minus the given angle 70 divided by 2. It will be 55. Then you find that this one is 55 and this one is 55 like we want. If this one 55, it will be like this measure, 55 also. Then Measure of angle Z equal measure of angle MLZ equal 55 degree. Then the two base angles are congruent. The two sides ML equal MZ. That's what he need and the question has done. I need you to remember that the meaning of axis of symmetry is the straight line perpendicular to the midpoint of a line segment. It's called axis of symmetry. Here is exercise about the axis of symmetry of the corollaries of the isosceles triangle. If you have that AB equal AC, or it's isosceles triangle, and it's given that AE is the bisector of angle BAC, required to prove that BD equal CD means I need to prove that the small triangle is isosceles or the two legs are equal in length. Looking to the givens that you have, AB equal AC and a bisector. Like I said before, if it's called the bisector, depends that the bisector divides the vertex, it will divide also the base and be perpendicular on it. If you prove that this base is perpendicular, you need that AE is an axis of symmetry. Means since AB equal AC and AE bisector of BAC, also BE equal AC because the bisector divides the base, also it will be perpendicular and called axis of symmetry of triangle ABC or axis of symmetry of the line segment BC. Then after that the distance will be equal. If the distance are equal, AB equal AC, BE equal CE, also you get CD equal BD, and that's what he needs to prove. All these exercise about the isosceles triangle, and it's the end of Unit 4. Unit 5 is talking about the inequality or the inequality. Means if two angles are not equal or two sides are not equal. If two sides have unequal lengths, the longer side is opposite to the angle with the greater measure. Also the shorter opposite to the smaller in measure. Like we said, the equal angles opposite to it, congruent sides and angles are equal. Here unequal, also the longer will be opposite to the greater, the shorter opposite to the smaller. About the right angled triangle, all the time the longest side is called the hypotenuse. And also the obtuse, the side opposite to the obtuse angle is the longest, means the right angle and the obtuse angle, the hypotenuse and the side opposite to the obtuse are the longest sides. In any triangle you have the sum of any two sides, in this triangle is greater than the third, two of them greater than one. The length of any side also in the triangle is greater than the difference, smaller than the sum. Again, greater than the difference and smaller than or less than the sum. And here's a prelude of this part. Any length located between the difference and sum. The length will be smaller than the sum and greater than the difference. Check this exercise. Exercise number 1. He will not give you two equal sides. He will give you side greater than the other, and he need to prove also another side is greater than another side. AC is given that it's greater than AB. AC greater than AB. The 2 points y and x located on these two sides. He need to prove that the small part YC is greater than XB. How to prove that? First of all, in triangle AXY, the small triangle, it's given that measure of angle AXY equal measure of angle AYX. If the two angles are congruent, then the two sides are equal. When you prove that the two sides using the isosceles triangle theorem, AX equal AY. If AX equal AY, we consider it number 1. Number 2, it's already given that all of AC is greater than AB. If the AC greater than AB and two parts of them are equal, then the small part here remaining, if we subtract between them, we will find that YC greater than XB means by subtracting 1 from 2, subtracting the equal part from all the part, you will find that YC greater than XB. Another exercise that here you have a triangle ABC. In this triangle you have two exterior angles. The exterior angle here is 110, the exterior angle here 120, and no interior angles are given. But he gave you that the point D belong to BC and the point E belong to AC. It's given also that measure of angle ABD 110, BCE 120, like I said before. He needs to prove that AB, the side AB, is greater than BC. If he needs to prove that side greater than side, we need to prove an opposite angle greater than an opposite angle. How to prove that this angle is greater than this angle? First, look at the triangle ABC. Since the point D belongs to the BC and it's called exterior angle, then the angle beside it will be supplementary and it will be 180 minus 110, it will be 70 degrees. If this angle is 70, also since E is a point belonging for AC, belong to AC, then this part will be 180 minus 120, and we get this part is 60 degrees, and they are supplementaries. Both of them are supplementaries. If this angle 70 and this angle 60, you can get measure of angle A because we need it. You can say that one measure of angle A equal 180 minus 60 plus 70, it will be 50 degrees. Then we get this one is 50 degrees. If measure of angle A is 50 degrees, then measure of angle ACB is greater than measure of angle A, and that's what we need from the beginning to prove that this angle greater than this angle, then the two opposite sides, the side opposite to it, AB, is greater than BC, and that's what he needs to prove. And then exercise number 2, talking about quadrilateral ABCD. AC is not drawn, but here we can use drawing AC, a construction, because this theorem is talking about an equal length in triangles only. But we don't have a triangle, so you can construct AC drawn from A to C to be having two triangles like that. By constructing or drawing AC, you have triangle ADC. It's given that AD equal DC means now you have an isosceles triangle ADC. Since AD equal DC, you will get the two measures of these two angles, and let me call this angle 1, and here is 2, 3, 4. I call them by numbers instead of, or easier than saying DA or DCA, it will be long. Now you can say that measure of angle 1 equal measure of angle 2 in the first triangle. Now in the other shaded triangle ABC, it's already given that BC greater than AB. The two angles opposite to these two sides will be that measure of angle 4 greater than measure of angle 3. By adding these two steps means by adding 2 to 3 will get an angle, and by adding 1 and 4 you will get another angle, but adding 1 to 4 will be greater than 2 to 3 because the biggers are greater than the smallers, and this is the theorem of the inequality from the lesson 1 in unit 4. Means by adding 1 plus angle 4, it will be greater than angle 2 plus angle 3. Angle 1 plus 4 is called angle A, means angle A is greater than measure of angle C, which is consists of 2 and 3. And that's what he need, the question has done. Exercise number 3, Also, it's a quadrilateral, but here is drawn a line between two parallel lines. It's given that XL parallel to ZY. The two measures 30 and 70 are given. The blue one here, it's given. But here, I complete the triangle here in these steps, but I wrote here to know it. Now, if you have LX parallel to ZY, you can have letter Z alternate angles. This angle equal to this angle, so you can find that measure of angle LXZ equal XZY, both of them 30 degree, and it's alternate. In triangle XYZ, if you have this one is 70 and this one 30, this one is given and you give the 31. Now you can give the 80 degree by yourself by finding 180 minus 70 plus 30. You will find that measure of angle Y is 80 by using the properties of the triangle. If you find this one is 80, means the side opposite to the 80 degree is greater side. Then ZX is greater than any other side. ZX now, or XZ, is greater than ZY. In this example, pay attention for the required. Required to prove that ZY smaller than XZ, smaller than, not greater than. Pay attention because not all the questions he asked about proving it's greater, but he need to prove it's smaller now. Means when you prove that XZ greater than ZY, at the end, don't forget to vice versa this statement to say ZY is greater than, it's ZY smaller than XZ. At the beginning, you proved XZ greater than ZY, and you have to give that ZY is smaller than XZ. This is the end of exercise 3, and exercise 4 now is just an example about a triangle, but it's not drawn, it's just written like a complete and choose questions, but it's here written that ABC is a triangle in which AB equals 6 centimeter, AC 8 centimeter, BC 7 centimeter. If you have the three sides, you can know now which one is the smallest and which one is the greatest side, and opposite to it the angles, and he needs to order the measure of its angles using descending way. I need to arrange them descendingly. From big to small, from the biggest side is AC. Since it's AC greater than BC greater than AB, the opposite angles, and pay attention for that. How to know the opposite angle without drawing? Here, if you have AC, you have two letters now. The missing letter is B, means the opposite angle is B. It's greater than, the side is BC. The opposite angle is the missing letter, which is A. AB is opposite to it, the missing letter, which is C. Means measure of angle B greater than measure of angle A greater than measure of angle C, and now you have arranged them descendingly. And this is the end of lesson 2. Lesson 3, all of its questions comes in complete and choose without proof, and don't forget to study it very well from your school book, the examples and the models at your school book. I wrote to you the choose and complete question. I didn't give to you all of them at the final revision sheet, and don't forget your school book examples for more ideas. Thank you, good luck, and goodbye.